And I'm here today with Billy Hollis. So Billy, why should developers care about user experience?
Well, if they don't care about user experience, they risk being displaced by people who do. The basic thing developers probably don't get that they need to understand is that user experience is reaching the point where, number one, people expect it, but number two, people are emotional about it. You look at people being attached to their iOS devices. People buy iPads for $500 or $600 back when they first started becoming such a hit. I asked people why they did that, and the most common answer I got was, I didn't know what I was going to do with it, really. It just felt so good. I touched it, and it just had that immersive, intuitive way of operating, and that emotional connection causes users to seize onto new technology in a way that is eventually going to percolate through the entire development ecosystem. So if you take, say, someone who's 24 years old who has only used modern app technology, their music player was an iPod and their first phone was a smartphone and they have a tablet, then you put them in front of the typical corporate app today, then the emotional experience for them is not very good. It doesn't increase connection to the company that they're working for. So there are some changes in terms of expectations, and of course there are economic reasons to do it too. Modern apps, if they are well designed in some of the actual situations where we've created them, have promoted user experience at 10, 15, 20% or more. If you have a decent sized user base, you're looking at substantial amounts of money, 7 and 8 figures per year of money saved for a small fraction of that in terms of investment in development. Design typically does not increase development cost more than 5% or so. Good design doesn't. So for that 5%, you can enormously increase the return you get on the investment of software development. Well, that becomes a competitive advantage. There are other reasons too. Good modern apps with the technology that's available are able to give visual signals to the user that allow them to decrease the number of errors that they make. And in some fields such as healthcare, that's just critical. That this older mainframe software, which I'm surprised how much of it is still out there, is literally killing people each year because there's not the kind of feedback that would prevent errors. So there are all kinds of reasons to do it, but for individual developers it comes down to, as the understanding of this value gets out and the expectation level goes up, then the developer either has to be able to do it or risk being de-emphasized or pushed aside for somebody who does. No development team wants to be in that situation of having an executive come in and plop that tablet down and say, why isn't our stuff running on this?
Okay, so in your course you talk about archetypes. What are archetypes?
Archetypes, that's the idea of an expected near universal form. So if you are playing media, you expect to have the VCR type controls. That was designed and refined about 30 years ago as VCRs became popular. And then it made the transition over to software. But if you did media control any other way, you would pay a price in terms of people not understanding it. You would have to do something really, really well. Say the iPod kind of varied that model a little bit and did pretty well. But in general, unless you have an extremely good and compelling alternative, you stick with archetypes. You don't want to make your buttons in your user interface weird shapes, because people expect buttons in a user interface for the most part to be rectangular. You might make a round button to make it stand out, but if you're trying to do routine things, then you keep those forms as in terms of what people expect. So that also applies to things like visualization, iconography, and such. That if you're going to do an application that works with doctors and you want to have a visual indicator, well, there's kind of a standard symbol for what a physician looks like with a stethoscope. That's an archetype of what people expect a symbol for a physician to look like. So whenever you're doing design, you'd ideally like to know if there are standard ways people are going to look at it and expect it, then you want to use those. You don't want to vary away from those just for fashion or for style. In my class, the example I tend to call out is an elevator panel that has round placards for the floors. And actually we are sitting within a few hundred yards of just such an elevator panel. It's over at the Signature here in Las Vegas. If you look at that elevator panel, very often you'll see, especially for the ground floor, that the paint is rubbed off on the placard because people are pressing it. Why? Well, it's round. When you get on an elevator, what shape do you expect the button to be? You expect it to be round. That's an example of an archetype. So anytime in software you have an expected form, there should be a fairly high resistance level to going against that. But it's just an example of a design principle. There are dozens of them that users that developers should know based on the way users think and act and how their brains work. And knowing these principles, which are not rules, by the way, they're guidelines, and they trade off against one another sometimes. But knowing these principles helps you to know what designs are likely to work well for people. And if you see a bad design, if it feels wrong, it helps you analyze what's wrong with it. So you could look at something that people just didn't understand and go, ah, yes, well, we're violating the archetype principle here. That would be an example of applying a design principle to user experience design.
So what is code addiction?
Code addiction. As far as I know, I coined that term. And I spent a lot of years in the 90s and early in the .NET era trying to help developers see that less code is usually better. That if you can do the same functionality with less code, you are producing more value. And I find that my own coding technique, which comes from learning Fortran with punch cards, I tend to think through what I'm doing a lot more. I don't play out my thoughts in a code editor. I already know when I walk up the code editor what I'm going to do. So I'm not a code addict. But there are a lot of people, and in fact I think that the industry is kind of selected for these people, that they're the ones who have done well over the last 15 or 20 years, who have a visceral delight in writing code. The actual experience of writing code is very, very emotionally appealing to them. And I started first noticing this back in the 90s, that people would put aside other activities that they ought to do in order to write code. The classic diagnostic case that I tell audiences is, have you ever been in that meeting where someone is going to describe a module to you and it's going to last 90 minutes, it'll take them that long to describe it, but after 10 minutes you're not listening anymore because you're coding the solution in your head already. That urge to think about code is so strong that it displaces other activities you ought to be doing, such as listening. And I jokingly call that code addiction because it does have certain aspects that are not unlike addiction. I joke that, for example, that it's worse than smoking. Most people can put smoking aside for 90 minutes and listen, but they can't put code addiction aside for 90 minutes. And I have a variety of jokes. I play on words that I use for that. I talk about code heads versus cokeheads. It's only one letter difference, and that both kinds of addict get their satisfaction by doing some lines. And so developers laugh at that because there's a certain amount of truth to it. It's not that I literally think that they are substance abusers, but when people find themselves inventing reasons or excuses to avoid other aspects of their job just so they can write code. They don't want to listen to users. They don't want to do documentation. They don't want to think about requirements. They don't want to worry about the testing and things like that. If they're putting off the things that make the application good just so they can write code, that's really not a good thing. You can't afford in most environments for the entire team to be made up of code addicts. You can afford to have a few, but there better be people on that team that are able to put code aside and understand the relative importance of other aspects of software development.
So as a pioneer in the .NET space, where do you think the future of .NET is going?
The future of .NET, that's a tough one because we are in such an era of extraordinarily rapid change. I believed when .NET was created that there was a need for a platform that wasn't so dependent upon the operating system or whatever, that would stay consistent over a long span of time. And .NET's pretty successful in the scheme of things because it was released in 2002, was in beta a couple of years before that. So we are now at 12 years and it's still going strong as a platform, even though I think it probably has peaked. But you look at previous platforms, Most of them didn't last that long. A few of the IBM platforms did. But in the 90s, Visual Basic was the dominant platform. And from the time Visual Basic was released, the first version was released, until the last version was released, was only 7 years. So that's how long it lasted as a platform. So .NET's done pretty well. The future of it, if I were smart enough to know that, Paul, I'd probably be out on a yacht somewhere. So it's hard to say. It has grown in complexity to the point that no one person can master it. There are parts of it now that are obsolete. The thing that I think is going to be needed to replace it, though, has not been created yet. This idea that we're going to replace .NET with this melange of open source technologies, that you just got to figure out how to fit them all together and nobody's responsible for tech support and things like that. There might be some places where that stuff works pretty well, but I don't think that typical business corporate software works very well with that kind of a philosophy. So .NET certainly has a pretty big role to play there. The thing that would replace it in that context, in the business context, really hasn't been invented yet. I kind of think about what it looks like based on what I know about the evolution of the industry. It would involve much greater separation of business logic from plumbing. Because right now, the .NET systems that we create don't do a very good job of that. We just mix the plumbing and the business logic. We got a bunch of layers. We got a device on one end, or maybe a desktop. We got a database on the other, and just layers and layers of plumbing in between. And the business logic is just in there like fat through muscle. You can't separate it out. So that really needs to be a separation. There should be people worrying about the business rules and how they work, and not caring about the plumbing at all. And I think we will eventually see a system that enforces better separation there, where the business rules can be in more of a metadata repository. Many of them would look like code, but they wouldn't be in traditional code modules. They would be in smaller pieces that the plumbing knows when it's appropriate to run them. Think data validation, for example. There's absolutely no reason that data validation ought to be in code. Well, there are scenarios where it should, but for the typical routine business case, the data validation ought to be in a repository somewhere, and the plumbing knows when it needs to get run and how to reflect that information to the user, and we don't have that now. Typical .NET systems just have all kinds of kludges to detect errors and send them to the user. So that kind of metadata-driven system, I think, is going to have to arise before .NET will face a serious challenge, and I don't see that yet. Now, the cloud may very well be the motivating factor to get to that point, because it's a lot more practical to create that kind of metadata-driven system with engines that figure out things such as how do you display the UI, how do you generate the UI for device X. Let's talk to this device, figure out what capabilities it has, and generate an optimal user experience for that device. What company would ever develop that kind of sophisticated logic? Well, probably nobody would for a corporate application. But if one of the cloud providers creates it, there is an enormous incentive for corporate application developers to use it. So the cloud makes that much more feasible. Just as the cloud today, most of the voice recognition that we use takes place in the cloud because the device isn't smart enough to do it. I think we'll reach the point where the very UI that goes out to the device is figured out in the cloud. Based on what it finds out about the device, it will know what the user needs to see and have enough capability to optimize the experience for that device and then just spit it out. So I think that kind of metadata-driven system with a lot of generated UI is some point off into the future. I don't know how far, but I think it's almost inevitable because of the enormous complexity of .NET and all the web technologies that surround it. And you look at the typical Visual Studio Solution Explorer today for even a not particularly complex web app, but one that talks to services and one that's got how many things are over there in that big hierarchy? Dozens and dozens and dozens. And it's really, we're stressing that conceptual model to the breaking point. And that's .NET's big weakness right now. There are too many pieces, and it's not obvious to the person that walks up to these pieces which ones are important to them and which ones are not. So I think that's where .NET needs to be. Something needs to be created that will evolve beyond that. And a standard design principle is when you get to that point of complexity, you want to learn how to hide the things that the people don't need to care about right now. Well, the things that most business application developers don't need to care about is plumbing. Ideally, they wouldn't care how the data gets from here to there. They would just say, get it for me, let me change it, here, take it back. They don't really need to care about that plumbing. Right now they have to. But in a cloud-based world with much, much more sophisticated plumbing, where the business logic is separated out, they wouldn't have to worry about it. And I think that will, if such a successful system comes along, that's going to be the next big competitor to .NET.
Okay, one more little bit of crystal ball gazing. So now that touch has become a fairly common model for user experience, what do you see the next big evolution in user experience being?
That's a really good question. And again, I'm not smart enough to know, but I can list some of the candidates. Voice recognition is finally getting to a point where it has become an option for certain application scenarios. They've got it so good that you can stick this, Amazon just introduced this week, this device you stick in your house that kind of is a Siri. It's got a speaker and a microphone, and it's tied into the cloud, and you ask it questions and it answers. Well, that's, nice science fiction technology, and that sort of stuff I think can be leveraged for some application scenarios. Then there's gesture computing. There are all kinds of new devices coming out that detect hand gestures, and then there are others that detect brainwaves. Those have certain interesting places that they might be applied. I've played with some of the gesture computing things, for example. And I think about, someone who is going to be in a hazmat suit because they've got to take care of an Ebola patient, but they need access to a computer system. Well, they can't touch it, and they can't type, they can't, pretty clumsy to use a mouse with that big mitten on, but you can certainly imagine that they would have a gesture band underneath that suit that would allow them to just gesture with their hand and interact with software. Or a surgeon that is doing an operation and needs to manipulate the MRI that guides him. The ability to zoom it and move it around, he could do that with gesture. The problem with trying to figure out what's going to go beyond touch is that touch has the capability of being pretty ubiquitous, more so, for example, than mouse and keyboard, because mouse and keyboard take up a certain amount of room, which means that you can use them on the desktop, but you can't just carry them around with you all the time. Touch certainly has that, as we've seen with smartphones. So touch has this wonderful ability to be ubiquitous. Anything that's going to make a serious challenge to touch has to be just as ubiquitous, and voice and gesture aren't as ubiquitous. Voice has trouble with noisy environments. Gesture has kind of, at this point, we don't really know how to have a good gesture language that will do all the things that touch will do. And then, I don't know, maybe brainwaves will be as useful and ubiquitous as touch when they figure out how to do it. But I think touch has got a pretty long lifespan ahead of it.
All right, well, thank you very much, Billy, for talking to us today.
You're welcome, Paul. Happy to do it.